All right, friends, welcome back to our second week of inequalities. So we started talking about inequalities last week. We looked at it. We can look at the greater than. So say you had like, I don't know, all the milk in the fridge has to be kept below 4 degrees Celsius. So that would mean you would have, say, X is the temperature of the milk. You'd have X has to be less than 4 degrees. Or if you said the milk has to be kept at or below 4 degrees Celsius, you'd write X has to be less than or equal to 4. Okay, so that was the difference between our less than and less than or equal to, and the same idea with greater than and greater than or equal to. And when we showed those things on a number line, remember that if something was less than or equal to, then the dot of whatever it was less than or equal to, so say it was 4, you'd have a filled in, colored in dot on 4, and then the line, your colored in line would go to the left, right? So if it's less than or equal to, we go to the left, plus we include the dot. If it was just less than, not less than or equal to, there'd be a little circle around the 4, and then the line, the red line, would go to the left. And the same thing for greater than and greater than or equal to. So if you're including the number, you color in the dot. If you're not including the number, you don't color in the dot. So this week we're going to start looking at what happens if we have our inequality written and then we add or subtract something from it, or we multiply or divide with it. Okay, so we're going to start with the idea of adding and subtracting from each side of an inequality. And if we look at the page here, we say we can use a number line to investigate the effect of adding to and subtracting from each side of an inequality. Okay, so if we look at this, we see there's a red dot on -2 and a red dot on 4. Okay, so we're going to add the same number to each side of an inequality. Let's do it. So here's our inequality. -2 is less than 4. Yep, it is. Okay, so we're going to add 2 to each side just to try something. Okay, so we're going to say, okay, we're going to do +2 and +2. So we start here. If we add 2, we get to 0. We start at 4 and we add 2, we get to 6. Is 0 less than 6? Yes. So the same thing holds true. Okay, so if we add the same number to both sides of the inequality is still true. Okay, so what about subtraction? Look, if we have the inequality -2 is less than 4, yep, there's one, there's the other on the number line. Subtract 1 from each side. Let's try. Okay, so we have -2 minus 1. And on the right, we have 4 minus 1. So -2 minus 1 will be -3. And 4 minus 1 will be 3. And is -3 less than 3? Yes. Okay, so it's still true. So if we subtract the same number from both sides, then that inequality is still true. Okay, so that's what this rule says down here. All right, so let's try an example. Oh, I was just going to show you this. So look, if we're going to solve an inequality, you do it the same way you would solve an equation. Okay, so remember we were solving equations before like this one, h plus 3 equals 5. All right, well, how would we isolate h? Well, we have to get rid of that +3, right? So the opposite of +3 is -3. We're going to have to do subtract 3 from both sides to get h all alone. There we go, h plus 3 minus 3. And 5 minus 3. So our left side becomes h, our right side becomes 2, and we see there's a solution of h equals 2. Solving an inequality, same idea. Okay, so when we're solving an inequality, it's the same process. It's just we're working with an inequality sign instead of an equals sign. Okay, so again, we'd start by saying, okay, if I want to isolate h, I got to subtract 3 from both sides. Let's do it. And we end up with h is not equal to 2, but it's less than 2, because this was less than 5. Okay, so we still have 2 sides to our inequality, just like we have 2 sides to our equation, a left side and a right side, but here we have an inequality sign instead of an equal sign. Okay, so the difference too with an inequality is we have a whole bunch of solutions. H can be anything less than 2, so it could be 1, it could be 0, it could be -756. Those are all possible solutions to that inequality, whereas an equation only has one solution. So we'll look at an example of solving an inequality. We see the inequality is 6.2 is less than or equal to x minus 4.5. Okay, so what are we going to do? Remember, we want to find out what x is equal to. So we need to get rid of this minus 4.5. So we know what to do. The opposite of minus 4.5 is plus 4.5. So we're going to do that on both sides. There it is. 6.2 plus 4.5 is 10.7. So x is greater than or equal to 10.7. That means it could be 11, it could be 20, it could be 30, okay? Those are all possible answers. So to verify that, look, you pick any of those answers you want, okay? So say you pick, okay, so anything that's greater than or equal to 10.7. But here they said we're gonna pick 11, okay? So our left side is 6.2, see, 6.2 is the left side. Our right side is x minus 4.5. That's where that comes from. So now we're going to substitute 11 in for x. 11 minus 4.5 equals 6.5. So is 6.5 greater than or equal to 6.2? Yes. So it's correct. Okay. So you could do it with other numbers too. Okay. So they're going to show you a bunch of different possibilities. The last step that it asked you to do in this question was graph the solution on a number line. So if we said x has to be greater than or equal to 10.7, here's how you would show it on a number line. So you show a number line starting a few numbers before 10 and showing a few numbers after 10. So we do 8, 9, 10, 11, 12, 13. We put our dot on 10.7, and then we color in to the right of 10.7 and put our little arrow at the end. Okay, and the dot is filled in because it's greater than or equal to. If it just said greater than, we wouldn't fill in that dot.